Hello students, in today's class we will continue the chapter motion in a plane, that is we'll study about product of vectors, that is dot product and cross product, their properties and some examples. Later we'll define some definitions related to projectile. Let's study the dot product of vectors, that is also called as scalar product. The dot product of two vectors is defined as the product of magnitudes of two vectors and cosine of the angle between them. As you can see in the diagram, let A and B be the two vectors. If theta be the angle between the two vectors A and B, then their dot product can be given as A dot B is equal to AB cos theta. So let's study the properties of dot product. The dot product is commutative. As you know the rule of commutative, A dot B is equal to B dot A. Next, dot product is also distributive, so that A dot B in the brackets of B plus C is equal to A dot B plus A dot C. Next, dot product of two vector is maximum when vectors are parallel, that is theta is equal to 0 degree, that is cos 0 degree is 1. So we can write the equation as A dot B is equal to AB. Next, the dot product of two vector is minimum when the vectors are perpendicular, that is 90 degree. So that cos 90 is 0. So A dot B is equal to 0. Let's go to some examples of dot product. Let's define work. What is work? Work is force into displacement. So for dot product, work is equal to the dot product of force and displacement. We can write it as W, that is work, is equal to F dot S. That is F is force and S is displacement. And we can write it as Fs cos theta. Next is power. Power we can define as force into velocity. So power is equal to the dot product of force and velocity. P, that is power, is equal to F dot V, or we can write it as for dot product Fv cos theta. Next, under product of vectors, we will study cross product, that is vector product. The cross product of two vectors is defined as a vector whose magnitude is equal to the product of the magnitudes of the two vectors and the sine of the angle between them. As you can see in the diagram, if theta is an angle between the vectors A and B, then their cross product is given by A cross B is equal to AB sine theta. So let's study the properties of cross product. The cross product is non-commutative, that is A cross B is not equal to B cross A, but A cross B is equal to minus B cross A is possible. Next is cross product is distributive. A cross in the bracket of B plus C is equal to A cross B plus A cross C. Next is the magnitude of cross product of two perpendicular vector is maximum, where theta will be 90 degree. That is sine 90 can be 1. So A cross B is equal to AB, that is maximum. Next is cross product of two parallel vectors is minimum, where theta will be 0 degree or 180 degree, because it's a parallel vectors. So what happens is A cross B is equal to 0, which will be minimum. That is sine 0 degree or 180 degree is equal to 0. So A cross B is equal to 0. Let's go through some examples of cross product. The first one is torque. The torque is equal to the cross product of position vector r and the force F. We can write torque, which is tau, is equal to r cross F. Next is angular momentum, which is equal to the cross product of position vector r and linear momentum p. We can write angular momentum L is equal to r cross p. Let's study the concept of projectile. Later, you need to derive the equation for the trajectory of a projectile. So, we have to understand the concept of projectile. What is this projectile? An object thrown into a space which moves under the effect of gravity alone is called projectile. Let's understand this projectile motion. The motion of an object thrown into the space under the effect of gravity alone is called projectile motion. For example, a body is released from an airplane. How it moves? That motion is called as projectile motion. And a bullet fired from a gun. That is also a projectile motion. Let's study the concept trajectory. The path followed by the projectile is called trajectory. As you can see in the diagram, a guy thrown a stone, so that is projectile, and the path followed by that projectile is called as trajectory. So don't confuse with the projectile and the trajectory. The path followed by the projectile is called as the trajectory. The next one is the trajectory of the projectile is parabola. As you can see, it is in the form of a parabola. Let's study some basic definitions of projectile. Point of projection. The point from which an object is projected into space is called point of projection. Next is velocity of projection. The velocity with which an object is projected into the space is called velocity of the projection. Angle of projection. The angle between the direction of the projection of an object and the horizontal direction at the point is called angle of projection. So as we have studied about the projectile motion, here are some of the assumptions made to study the projectile motion. The first assumption is that the projectile is considered as a particle. It is nothing but a point mass. Next is the acceleration due to gravity is constant over the range of motion and it is directed vertically downwards. Next is the effect of air resistance is negligible in the projectile motion. The rotation of the earth does not affect the projectile motion. So these are the assumptions made for the study of projectile motion. Let's study some more basic concept of projectile. What is the maximum height of the projectile? It is the maximum vertical distance traveled by the projectile. Next is range of projectile. What is this range of the projectile? It is the maximum horizontal distance traveled by the projectile. Time of ascent. It is the time taken by the projectile to reach the highest point from the point of projection. Next is time of descent. It is a time taken by the projectile to reach the ground from the highest point. Next is time of flight. It is time taken by the projectile to return to the ground from the point of position. That is total time. Time of ascent and time of descent is equal to time of flight. In the next class, we will derive the equation for the trajectory of the projectile and the expression for the maximum height, time of flight and the range of a projectile.